software optimization. I will also try to show you what to do to success of your software of your product not became a disaster. As I said, I'm Przemek Nowak. I'm working over 17 years on all stages of software development. I drive, before I started to work in Wro, I ran own company, which was specialized in custom software delivery. Therefore, I have huge experience in many different types of systems, from typical e-commerce and for B2B or B2C market systems, through some system dedicated to specific solutions, for example, factory management, etc. And also complex research systems. So the main goal, main common part of all the systems was always performance as an important part of the product, because as you know, in e-commerce, in production, in research, the time to deliver results is the key value of the product, except of course features that we can deliver. A bit updated photos. You can see I start really early, and it was strange time. This was computer. This was only a keyboard. that's why I have big respect to the resources. When I started, not then, few years later, we have to put all data in, for example, 8 kilobytes of memory. We had only one CPU, one core that works at frequency of 1 megahertz. That's why I focus on the performance from the beginning. That's better. It's current photo. I forgot. I invite two guests. Let me introduce you, Robin and Bob. They are team leaders in one company that they where they want to perform some kind of experiment. They have to provide exactly the same application with the same technology, the same features, but development process will be processed in two different ways. The green team, led by Robin, will introduce performance testing and optimization in the process of development. On the other hand, the blue team, managed by Bob, will try to deliver software as fast as possible without focusing on performance in the development process. We'll see how the experiment will begin. Okay, software optimization. I believe that every one of us feel what is software optimization, but let's maybe try to define it. I know it's boring, I cite Wikipedia, so maybe let's focus on highlighted words. So the software optimization is the process of transforming one system into another where we want to reach the product that will work more effectively, or which will be used fewer resources. Why optimization matters? For the first reason is it's typically use lesser resources, whatever it is: CPU, RAM, storage, bandwidth, or whatever we can imagine. The next reason, we use therefore less power. We can proceed our actions faster, deliver results quicker. By the way, we care about ecology, and simply using well-optimized and working fast software doesn't give us more joy. But in reality, it's all about money. Here we can see some examples when shortening the time of rendering page or generally delivering the content allows to increase revenues or another benefits. On the opposite, when we increase time of, for example, page rendering, we lose something. For example, Google says that they lose 20% of the traffic when for each additional 100 milliseconds. It's impressive because we can simply imagine not well optimized page which runs, for example, 5 or 7 seconds. How many traffic we can lose when we not optimize our software? I believe that you know more examples, but it's only a pattern that I want to show. The common rule here is longer worker. Let's see what's happening in our teams. As you can see, both teams finished decomposition of stories that they have, and they start working. The blue team started developing the features. They already have 5% of the features done. On the other side, the green team start planning of the testing environment. As for now, not a huge difference. Go further. Okay, so let's optimize something. But before, I thinking a lot before this presentation how should I share with you my experience and my knowledge, because I know that we are here are mostly developers that use different technologies, and maybe some of you don't use any development tools or technologies at all, because perhaps you are manage or selling IT products. So I decided to not go too much into the technical details. If you will have any questions, I will happy to answer you later. But let's take for some theory. Problems. What typically forces us to thinking about performance? It's typically problems when we usually think about optimization too late, when the problems occurred, not in the process of planning software. So the first typical problem is load time, especially now when modern applications are very often one-time solution, when you have huge initial time to load all assets, load external libraries, mediums, etc. Another problem is response time. When application is already loaded, when user click on a given button or want to perform given action, reaction of application between clicking on user interface and send the response is too long. Another problem is inability to scale. Very often we test our application on a very small set of data or very small amount of users that we push against the application. In real cases, we can meet the situation when application don't respond as fast or at all when we put huge traffic on it. And bottlenecks, that's all the problems that we can meet that lower the performance of application on any level. That can be an architectural problem or problem in the storage level, whatever it is, we can classify it as bottleneck problems. And unreasonable resource consumption. When we have wrong setup, wrong configuration, or wrong architecture, we can run at the certain moment we can run out of resources. For example, process that takes a lot of time can have a memory leak, and we finally finish with failure. What metrics and tests can we attach to our system to measure and then detect that problems? Metrics. Speed. Of course, it answers us at the first and third question. What is initial loading time? And what is response time of the application? We can measure scalability, its ability to, of application to taking as huge as possible, as huge traffic as possible. Stability. We can determine the point at which application will fail in terms of number of users we put on. And resource of utilization. We can check, for example, load of the CPU or memory usage. To measure these metrics, we can use many types of tests, but in my opinion, there are only 4 important tests from the practical point of view, because many of tests that we can meet in the internet or in other resources are only a combination of these 4 I present you here. The first type of test is load testing. It's typical test when we put certain amount of users during the given time to test behavior of the application. We can test every page on our shop, our web page, or our application, and check what is the load time, what is the response time of certain page. We can measure in the same time every parameters that I mentioned before, because during the test we can measure not only time of execution, but also resources and check stability. Second type of test is a scalability test. In this case, we don't put constant load, but we in every iteration we add some additional traffic to our tests. So we start from a level, let's say 10 users per second, and after next, for example, 20 seconds, we add another 10 users. This process iterates as long as possible to the rejection of answer. This allows us to answer how many users we can handle and how system will behave when we have any problems. Okay. Endurance, it's another type of test, also known as SOAK test. It's very important and not often performance test, but it allows us to answer to the question how system will behave in the long term of time. Typically, all tests tend to be as short as possible. We put as maximum traffic on our page and try to determine how many users we can handle. But if we have very complex cases and, for example, many tasks that are performing in the background, using, for example, some kind of customers, workers in the background that working not in the model of request response, but as a server, we can meet problems with memory lakes, with, for example, storage lake, for example, because we log too much. This kind of test allows us to check these issues. And the last one, it's very important test, volume test. Very often during load testing, we try to test application using small subset of data. For example, shop with 1,000 products, very often much less. This shows us perfect statistics. Okay, page loads very fast. Response time is great. But in reality, when we meet a customer who needs much larger database, the problems occur. That's why we should test using huge data sets. Okay, we know what we can measure and how. Let's see on the whole process, what steps we can take to perform the whole process from identifying our problems to improving it. There are in reality 4 steps that we have to take. Identifying the acceptance criteria, testing, analyzing gathered data, improving, and repeating, because it's not a single time process. Okay, small update from our team leads. Okay, the first visible difference is in the amount of in the progress. Blue team is strong focused on pushing new features. As you can see, they deliver some new features. They put some data using user interface that they provide. On the other hand, our green team implemented some mechanism to generate data for test performing. They already started basic architecture of the system implemented. I'm worrying about the difference, but as you can see, they also find 3 performance issues. Blue team 0. Let's look what we need later. Okay, let's back to the to our steps. The first step is to identifying the acceptance criteria. In project management, to do project management well, you have to clarify your acceptance criteria. You must know what you want to reach, what results you want to see at the end of the process. The same in project management. When, for example, using Scrum methodology, you break down the problem to the stories. Every story should have acceptance criteria to rate if we finish the given functionality. The same approach we should apply here, because we must know what product owner or customer want to, what results they want to have. We can use even Scrum, typical Scrum questions. For example, as a user, I want to see homepage in 2 seconds. As a backend operator, I want to search any customer in no more than 2 seconds. Another this type of questions. I believe that's important, but that's easy. But we should focus on 3 important factors. The first one. The requirements should be realistic. We can't require loading homepage in 0.2 seconds. Measurable. To be able to improve something, we have to be able to measure it. So it's obvious. And the last one, the requirements should have business justification, because we can flow into unrealistic and more in the terms of dreams and wishes requirements, but not the way. We can spend a lot of time on delivering such requirements, but important is that they should have business background. Testing. Testing is the most important process of gathering the data, and when we know what are the expectations, we should plan scenarios of tests. It's a quite simple project, but requires many attention, because we have to imagine all possible paths that user can follow, from the, for example, homepage to the finalizing the order in the shop application. Then we should prepare an environment. Now it's quite simple, because we have any kind of cloud services, so we can quickly set up test instance for our application, additional servers for testing purposes. So it's no problem nowadays. The most boring part is developing tests. You have to reflect all gathered information into the test scripts. It can be done in very different technologies, starting on the language or tool you use at everyday activities, to the highly specified tools. I'll mention about the one we use a bit later. The next part is very interesting because it's executing the test. Before we start executing, we should start some small tests to be absolutely sure that we have no defects in our tests. Then we can execute the test and gather the data. As a result, we get the data that show us application performance and other issues. It can have very different forms. For example, charts. At this example, we can see chart of response time of some page in 3 main ranges: below 800 seconds, below 1.2 milliseconds, and over 2.1 milliseconds. And failed requests. As you can see, we can see here that response time is quite good in this case. This is another example of chart when we can see more detailed I missed the word distribution of request times, also with errors. As you can see, red color indicates error. We have no errors in this case. Okay, some hints about testing. Prepare generators. As I said before, it's very important to testing on a huge amount of data. It's hard to prepare this data manually. Even if you try, you stop after a few hundreds of records. So it's a good idea to have written by yourself or by tools that are available on the market data generators. Safe data, test data sets. Even if you generate a huge amount of data, it takes some time. So to save your time later, you should save these data sets because you probably will want to use it again. Data sets should be as random as possible. This is because some mechanism in the database, in the storage layer, or another layers of your application that are able to cache similar data. Okay. The same with requests, test requests that you push against application. There are some layers that can cache your requests. Therefore, if we send the same request again and again, results are invalid. I said about time needed to generate large data sets. Your application probably is live. You still add new features, new code, and very possible that the structure of the database also changes. So you should plan also migration for the test data sets to prevent generating the data over and over again. And also, during the real tests, you should avoid logging detailed information. I know it in test environments, it's typical to log as much as data as possible to have material to analyze. But during performance testing, you should prevent this practice, and because the logging introduces a huge amount of time that is taken to storage these logs. And of course, don't use cache, because we don't want to test cache system performance and have perfect results. But we want to test our application problems. So if you use cache during the tests, this test can be it's not useful. Okay, I mentioned about the tool. We use many different tools. You can use as simple tool as Apache Benchmark. You can write your own script that will execute the tests. But we currently use Gatling. Gatling is a very interesting project because, first of all, it has a free version, so everyone can use it. But what's more important, it has a powerful engine that is running using Scala script. When you using object-oriented script, can write stories that covers all your needs in the application testing. You can supply it with big data sets of testing data, and simply run Gatling to perform all the work. What is interesting, easily you can increase the load that it put against the application. So you can make not only load testing, but also the tests, the failure tests, scalability tests. So if you're interested in tools, I recommend to check this one. And but if you don't like it, there is a lot of open source tools that you can find in the internet. Okay, the next important step is the analysis. This process when we reviewing the data we gathered to find some issues. We can observe, for example, response time of application in the numerical form. For example, we can see that this page is maximum load time is a bit higher than in other cases. We can focus on detecting why. Or in graphical form, we can see a chart when most of the requests are below 1.8 seconds, even maybe 1.5, but some group of requests are much longer, over 2.7 seconds. This indicates that we have some problem here. So we can focus on looking in the code, looking in our requests that were executed here to find the problem. Okay, and then we need to identify the component that makes a problem. It's depend on technology used. For example, we are a Symfony-based solution, so we can simply use Symfony bar to detail it, check what part of the application takes most time. Of course, you can use tools like Blackblaze or another tools that allow you to more precisely check what's happening in the application. But the main goal is to detect the part of the code that produces the issue. And then we have identified a specific source of the issue. Oh, our teams. Let's see. Okay, blue team again winning 75% of features delivered. They think that they have no problems with performance at all, but are certain that we'll win because features are almost complete. On the other side, green team generated a really huge data set of test data, and thanks to that, they found some issues in the architecture. They do some refactors to the code at the very early stage of the process. So I believe it will help them later. Okay, we have gathered data, we analyze them, then we should improve it. I will not give you now certain hints on it because it's mostly very depend on the tools you use, but in general, you should focus not only on the code base. It's modern systems are a very complex system. It's not only an application that works in limited resources. For example, in one CPU containing amount of memory, like in 8-bit microcomputers. That's a complex system of different subsystems. For example, we have a database layer, and we have application server, we have application itself. So the first step should be tuning environment, tuning your servers, tuning your database to reach as much as possible as performance only by optimizing the environment. I know that there are cases that simply parameterizing the web server and database can improve application four times faster. The code. If looking into and checking environment and tuning it didn't bring results, you should look at your code. We have every one of us, I think, have own methods to improve the code. So let's keep it. And one more thing, you should check architecture. If improving code at the very low level also didn't bring results, you should focus on the architecture, because very often when you start developing some application, you have some assumption, but in the time of developing or adding new features, the initial architecture can be not enough, and you should refactor also architecture of application, not only code base. I said I know not provide you some hints, but see, I'll try. Learning tools deeply. It's very important, because every framework, every database engine, every HTTP server has its own specific parameters or best practice that you should follow. For example, in Symfony, you should you should try to use as small as possible public services. In other cases, for example, you should generally you should follow the best patterns for tools you use. That requires to you much attention, observing the tool team that provides it, and learn from the best. Don't focus on substitute problem. Very often, when you try to find some problem, you detect some issue. But very often, it's not the problem you're looking. You're happy, you found something, and you stop. You improve it, you think the problem is gone. No, you should check twice if you really improve the process. Analyze and diagnose. I believe that we should leave prediction for fails, because you are engineers. You have to, using engineering method, for example, analyze, diagnose by checking hard facts, not your wishes. Do code reviews. It's very important to do code reviews, because another person can simply notify errors that you made in your code that you don't realize. Moreover, it's good practice to do code reviews across another teams, because when we do code reviews in the area of the same team, we have the same practice. We work on the same part of the code. When a member of the project from another team look at your code and have another experience, work on another part of code, he can help you by showing new solutions that you never know. But also, he can help you with the performance of your code. The same about architectural reviews. And look holistic. As I said, modern systems are very complex systems, so we can't focus only on one layer of the system. Okay, update from our teams. Okay, that's what I'm afraid. The blue team complete their features. They are very happy, madly happy even. And they will have to import customers' data soon. The green team found more and more issues. However, they still in the process of delivering features. But as I see, they do some very important optimization to some key mechanism of the application. Thanks to it, the application can work in parallel. Okay, let's see what will be after importing customers' data. I think I put here some slide from my conference of our gardeners. Okay, strange. Okay, I know, bottlenecks. Ogs are like onions, bottlenecks are like onions. Why? Layers. When you test performance of your application, you eliminate some sort of problems. You go one pass over the tests, fixing the problems, and you're happy because application work more stable or faster. But in reality, you should repeat this test many times. The limit can be, for example, related to the acceptance criteria, but in systems that are still in development, it should be performed regularly as functional tests, unit tests. It should be an element of your strategy of application delivery, because every line of code you introduce into your code base can make some problems with performance. That's why you shouldn't stop after eliminating the first layer of problems. The real case, we at Wro currently work on a very huge case when we have to test our application loaded with 10 million of products. Every product has multiple prices per product. It works on a multi-website setup. Every setup has many languages and multiple currencies. We tested front application on typical user behavior, from homepage to navigation on product catalog, basket activities, and creating the order, finalizing the order. What are the benefits of this testing? The first one was confirmation. We are absolutely sure that we can handle 10 million of products, even more. It's very important because we are targeted to enterprise market, so these numbers is quite typical for huge deployments. Real improvements. During the test process, we fix many bugs. We do some architectural changes that allow us to perform more actions at the same time. We prepare repeatable process of performance testing. So at a time, we can run our tests to check if application has some bottlenecks. And I believe that our awareness of performance issues rises because we talk about it regularly. So every person in the oral knows how important is performance of the final product. Oh, update from our teams. Okay, I see that the Green Team finally deliver all features. They found finally 18 performance issues that they solve, and the final result is perfect. They can serve page in 1.8 seconds. On the other side, the blue team has a huge problem because they load data from the customer, and application is unusual. They have so many bottlenecks that they can't even count number of issues, and they are of course depressed. It's of course overblown example. It's some kind of trouble because it's too ideal. In ideal case, they will of course additional costs of implementing tests at the very early stage of the process of the development. It is hard to define requirements to those tests at the beginning, but I wanted to show you that implementing tests of performance at the process of development is very important because you can start solve problems with performance before you deliver the application to the customer. At the stage before release, you can change architecture easily, more easily than later when you deliver the application to the customer. There are many benefits to the process, so I want to recommend that if you can involve this process into the development process. The conclusion. As I said, the performance test before product release. If you know your product is for enterprise market, don't test this as a product for Soho. You should simply with very big amount of data and put huge traffic on it. This was already said, and remember, onions, layers, testing, testing, and testing. I think that's all. If you have any questions, especially about technologies, I'm happy to. I will happy to answer you. And of course, pretty considerable use what in this presentation was on CC BY license, so that's authors of the icons.